In this video, we're going to talk about the product rule and the quotient rule for finding derivatives of functions that are products and functions that are quotients. First, let's do an example related to the product rule. The product rule says if you have a function h of x, which is actually a product of f of x times g of x, then the derivative of h of x cannot be written as f prime times g prime. Instead, if you see that your function h is actually one function times another function, then you must remember to use the product rule. It says the derivative of h is f prime times g plus f times g prime. I have written it in red and blue to make it really obvious to see. If h is f in red times g in blue, then its derivative, h prime, is f prime times the original function g plus f, the original function f, times g prime. Let's do an example. Down here in example 1, I have written an example h, which you see h is one function, 5x squared plus 3x minus 4, which I put in red, times another function in blue, 7 to the x. To find the derivative of h, we have to have these four pieces. Now, my recommendation to you is first to always recognize it is one function times another function, and I note to myself, okay, I say to myself, self, this is a product, one function times another, so I know to find the derivative, I have to use the product rule. And the product rule is one function times another function plus function 3 times function 4. That's what my derivative of h is going to look like. It's going to be f prime times g plus f times g prime. So in this first piece, I'm going to put f prime, the derivative of that function in red. So here it is. Here's the function in red. My first little piece here has to be the derivative of that, 10x plus 3. All right, there's f prime. Then I have to multiply that times g. G is this function in blue, the original g. I don't find its derivative, I just multiply times the original function g. Then I have to add to that f times g prime. F times g prime. So the original function f, that's the function in red, 5x squared plus 3x minus 4. The original function f times g prime. So now I'm saying take the function in blue and find its derivative. That's an exponential function, 7 to the x. So its derivative is itself times the natural log of the base. All right, there is f prime g plus f times g prime. This is the derivative of h. This is h prime of x. It can be simplified. It can be rewritten. But for now, we're just practicing using the product rule and finding the derivative. So please feel free to just leave it in this form. All right, next, let's think about the quotient rule. The quotient rule says if you have a function h of x, which is one function divided by another function, so one function f divided by another function g, then the derivative of h prime of x, you cannot just write it as f prime divided by g prime. No, no, no. That's a very common error. First thing you must recognize is I have one function divided by another function, so to find the derivative, I must use the quotient rule. The quotient rule says the derivative of h is f prime g minus f g prime over g squared. Notice again, derivative of the top times the original denominator minus original numerator times derivative of the denominator divided by the original denominator squared. Right? Again, it's setting up this template for you to find the derivative. So to find this, when I do this, the first thing I do is I set myself up this little template. I know I have a quotient, right? It's a big fraction. And in the numerator, I'm going to have f prime times g minus f times g prime. And in the denominator, I'm going to have g squared. So let's see what I do. I set myself up with these empty parentheses, and I'm going to go through and I'm going to fill in these parentheses with what needs to be in there. So the numerator I put in red, that's the f. The denominator I put in blue, that's the g. All right, and up here, the first thing is f prime, the derivative of the numerator. So I need to put here the derivative of that function in red. So that is an exponential function. It's got 25 as a constant out front. The function 0.8 to the x, that's exponential. Its derivative is itself 0.8 to the x, and you have to multiply times ln of the base, so ln of 0.8. There is the derivative of the numerator. Now I have to multiply that times the original function in the denominator, 7x squared plus 8x plus 1. So there's f prime times g minus, I have to multiply f times g prime over here. So f is the original f times g. F is the original 25 times 0.8 to the x. Now I have to multiply that times the derivative of the denominator, so g prime. That is the derivative of this function in the denominator down here. Derivative of the blue function, so that's 14x plus 8. Notice what I have in the numerator. F prime g minus f times g prime. Now in the denominator, I put the original denominator function, the original function g, squared. That gigantic fraction is h prime. F prime g minus f g prime over g squared.